Good day, everyone. Welcome back to Math 10 Combined. We're looking at the final lesson in this unit, which is 2.3 Part 2. We're going to continue to work with volume formulas today, and just like we did with surface area, we're going to solve problems where you're not trying to find the surface area or the volume, but you're given the surface area, or in this lesson, the volume, and asked to find a missing dimension. And this is on page 22 of your unit handout. I don't think this is going to take very long. We've got 4 examples we want to look at. The volume of an exercise ball is approximately 4,188.8 cubic centimeters. What's the diameter in centimeters? So clearly, we're going to be using the formula for the volume of a sphere. Even if you don't know what an exercise ball is, you know what a ball is. A ball is a sphere. So in yesterday's problems, what we did was maybe we were given a radius and we put the radius in and calculate the volume. Here, this number in the question is the volume. This is the volume. You can see it's the volume without even being told, although you are, it says has a volume, because it's cubic centimeters. So that number is going to go here. And we will have 4188.8 equals 4/3 pi r cubed. Now remember, when you are using a formula to solve for a variable, r is a variable, we're trying to solve for it. You do the substitution which we have, and then you simplify it. Well, the simple fact of the matter is there is a simpler way to write 4/3 pi. There's a much simpler way to write 4/3 pi. We figure out what it's equal to. 4/3 pi means 4 divided by 3 and then multiplied by pi. Well, how are we going to do that? Well, we have a calculator. So what is 4 divided by 3 times pi? What's this number? 4.18879. And now this equation is 4188.8 equals 4.18879 times r cubed. Well, very similar to the problems we did with surface area, to get the variable part by itself, since this is multiplication in here, we are going to do the opposite and divide by 4.18879. And what's going to happen, of course, is that this cancels with that, and you're left with r cubed is equal to whatever this number is. And I'm not saying that like it's a big mystery. I'm saying whatever it is, which we're going to find. We need to take 4188.8 and divide by that 4.18879. So divided by that number above it. And what we get is pretty much 1,000. Now, let's go back to 2 lessons ago. That number, 1,000, is not the radius. But in one of these lessons, a couple of lessons ago, we solved problems where you ended up having r squared equals, let's say, 32. And that meant that we had to take the square root of both sides. So you took the square root of this side, you took the square root of this side. When you take the square root of r squared, it turns out that you just get r. So r is equal to the square root of 32. And on our calculator a couple of days ago, if this was what we were dealing with, you found the square root function, and then you entered 32, and that was our answer, 5.7. So r equals approximately 5.7. Now, why am I going back to something that is not what we're doing today? The reason is it's very similar to what we're doing today. Today, we have r cubed equals a number, and what that means, I'm just going to move this over. I should have given myself more space. What that means is we don't take the square root, we take the cube root. Now, if you are using a non-graphing calculator, there is probably a cube root button. But on my calculator, and over time we'll learn other shortcuts, I have to go into the math menu to find the cube root function. The math key is 2 below the second key, which is the blue key on my calculator. It is approximately, let's see if I hit it, I don't know, not bad. It is approximately where that arrow is pointing. So I hit math, and then I can see down here it says the cube root. It looks kind of like crap. That's not how you would write it. You would write it the way I have written it here. This is how it should be written. Not with some ghostly 3 hanging way outside somewhere. But anyway, that's how it appears on the calculator. And then I enter that number. I'm going to go up and grab this number. And it's about 10. In one of the units coming up, everybody, we will talk about what a cube root means. Don't wrap your head around it just yet. Turns out the radius is 10. Be very careful here. This is 10 centimeters. I believe it's centimeters. Yep, but you were asked for the diameter. That's a shame for a student to get questions wrong on an exam because they forgot to double check what they were asked. The diameter is 20 centimeters, twice the radius. So that's example 1. Example 2, what is the height of a right pyramid with a base area of 4.86 square meters and a volume of 7.29 cubic meters? Well, a pyramid's formula for volume is volume equals 1/3 the area of the base times the height. So the volume is this number. The area of the base is this number. And it doesn't get much easier than this. Once you put the numbers in, you'll see why. We're going to have 7.29 equals 1/3 times 4.86 times the height. So you substitute, now you simplify. If you learn 3 things in this whole unit, one of them had better be, in general, how to solve an equation. You put in the numbers for what you know, you simplify, and then you rearrange. So how do we simplify this bit of business here? We take our calculator and we figure out what it's equal to. 1 divided by 3 multiplied by 4.86 gives us 1.62. Times the height. Oh, child's play. Divide both sides by 1.62 and we will have our answer. All right, right now we're multiplying h by 1.62. So we're going to divide both sides by 1.62. And of course what happens is these cancel and you're left with h equals equals what? Well, figure it out. 7.29 divided by 1.62, 4.5 units. Now I'm going to have to go back and look to see what they are. 4.5, our base area was in square meters, our volume was in meters cubed, which means our height is in meters. It seems to me when we did these types of problems with areas, we checked. Well, I'm not going to, but you could take that 4.5 meters along with the base area and put it into your volume formula and calculate the volume. You're going to get 7.29. You can trust me on that. What is the height of a right cone with a volume of 47.8 cubic units and a radius of 2.5? Well, this is something I tell my Math 30-1s a lot when we're dealing with certain topics in grade 12. Don't sit there and stare at a question and expect the answer to pop into your head, because it's not going to. You grab a formula. What's the formula? Well, it says a right cone. So you go to your formula sheet, you find the volume formula for a cone, and it's 1/3 pi r squared h. The volume is given to us. It is 47.8. The radius is given to us. It is 2.5. H is unknown. So we're going to put the numbers in. 47.8 equals 1/3 times pi times 2.5 squared times h. Oh, this is really, it should be getting simple, everybody, because this thing here is just a number. It's some number. So what you have is 47.8 equals that number multiplied by h. So to get h, we're going to have to calculate that number and then divide by it. Let's see what we get for that number. 1/3, 1 divided by 3 times pi times 2.5 squared. Don't forget your squared. Double check that. 1/3 pi 2.5 squared. 6.54-ish. Which means we have to divide both sides by 6.54. Of course, canceling the 6.54 and being left with h is equal to, well, whatever this is. $47.8 divided by my answer, about 7.3. Pretty sure it was millimeters. I'll double check. And I'm pretty sure it said to the nearest tenth. Yep. So 7.3 millimeters. One more question left, and it's not one where we have to rearrange any formulas. I just want to show you that if you're on top of your game, these do not have to be difficult. How much more air? Well, when we talk about air, we're talking about volume of air. How much more air is needed to fill a basketball with a diameter of 9 inches than a volleyball with a diameter of 8.4 inches? Well, first of all, let's just talk about radii, which is plural of radius. We're going to need to use a radius, which is half of the diameter. So for the basketball, half of 9 is 4.5. For the volleyball, half of 8.4 is 4.2. the volume of the basketball will be more. I know that a basketball is supposed to be round, and that's a little lopsided. But the basketball will have a slightly larger volume than the volleyball because the basketball is bigger. So I guess what we need to do is find the volume of each and subtract. And that's fine. You can do that if you want. But the answer to the question is the volume of the basketball minus the volume of the volleyball. And we know what volume is for these. It's 4/3 pi r cubed. So I'm trying to get you to think in broader terms here so that you understand things that are written down may look complicated, but they're not. That you should be able to think a little more abstractly and say this will be 4/3 pi times the radius of the basketball cubed minus 4/3 pi times the radius of the volleyball cubed. Now be honest, if you, on day one of this course, if you walked in the class and I had this written on the board and I said, this is what we're going to learn, you might just go running out the door. But this is not complicated. It looks complicated, but it's not. The volume of the basketball, is 4/3 pi r cubed, but we use the radius of the basketball. The volume of the volleyball is 4/3 pi r cubed, but we use the radius of the volleyball. This radius was 4.5 inches. This radius is 4.2 inches. I want to make sure I remembered them right, and I did. You know, I'm not saying don't write stuff down, but there comes a point where you don't have to write stuff down all the time. I can just enter this in my calculator in one fell swoop, which means in one shot. 4 divided by 3 times pi times 4.5 raised to the 3. 4/3 pi r cubed. I could hit equals right now, but why don't I just continue? Minus 4 divided by 3 times pi times 4.2 raised to the exponent of 3. So I have 4/3 pi r cubed with r being 4.5. I have 4/3 pi r cubed with r being 4.2. This is the answer to the question. 71 cubic inches. If you want, you can calculate the volume of the basketball and write down that number, and you can calculate the volume of the volleyball and write down that number and then subtract them. But I guess, again, I'm trying to challenge you to think in a little more high school way in terms of math. And what's in that rectangle, again, may look scary, but it's not that bad. You just have to think carefully, and you have to work in an organized way. That's it. The assignment is on page 87. It's question number 5, and I believe all of the parts of number 5 are simply asking you to find a missing dimension if you're given the volume. Once again, I think I alluded to this or mentioned it in the previous lesson. This is the final lesson. You have a quiz. Once you've done the practice work here, the quiz will be on surface area and volume. You're also going to have a unit assignment dealing with surface area and volume for a particular shape. And then once all of that is done, you can write your unit exam and then move on to Unit 2. I hope that made sense, and I hope you're all doing well. Take care. Talk to you soon.